Hey everyone, here we are going to complete the identity on the screen, and I'm going to, I think, show you two different ways that we can look at a problem like this one. So the first way is sort of my, no offense, but the rookie method. If I were not confident and I wanted to kind of jump into this with a foolproof way of beginning these, it might require more steps. It might be a little bit more long-winded, but it's usually a good way to start. However, when I do it with the more experienced person, more intermediate, person method, that way might seem longer. It's all going to depend on where this whole sum and expression appears, in what context, what are you doing, what else is involved. So one might be faster today, the next one might be faster tomorrow. It just depends on what you're working with, and it all comes with experience. Now that that's out of the way, let's look at method one. Method one is where, one, I get rid of any denominators, don't have any, looking great. Then two, I go into panic mode, which is writing everything in terms of only sine and cosine. So I'm just going to try to get a better bold pen because I've been using kind of a skinny one. So I'm going to leave sin²𝑥, theta, whatever, plus sin²𝜃 alone. No, you cannot combine these. This one is by itself. This one is a product of two things. They're not like terms, so you cannot combine them. But I'll leave those alone. I'm going to rewrite this using the quotient identity. So I'll start myself right over here. That means I have sin²𝜃, right? Plus, it was plus, right? Yes. Plus, nope, that's why I wasn't using, just kidding. That's why I wasn't using that pen. I need to throw them away when they're out of ink. That's what I need to do. sin²𝜃, I mean, I really like those pens though. So one day, if I'm ever a big time YouTuber, if Uniball Signo would like to send me pens, the bold ones, the really bold ones, because they show up on camera nice, that would be amazing. Pilot, I usually like yours, but the 10 is just not cutting it for me. Sorry, it's just not bold enough. The other ones are bolder, and I definitely use them all up. Times cotangent, so we said we're going to change cotangent into quotient identity. That's going to be cosine² theta, because it's squared, over sin²𝜃. So to me, this is more like the rookie approach, but it kind of works out really nicely this time, just saying. So because of the circumstances we're in, you have this being over 1. Multiply is really jumbo, simplify. So sin²𝜃 and sin²𝜃, that one's on top, that one's on bottom. This has nothing to do with anything. There's a plus sign there. These can reduce. Anything divided by itself is 1. PEMDAS, we've established this, I hope, is sort of a lie. You can divide before you multiply. What do we have? Next is sin²𝜃. That's this guy right here, okay? See, right there. And then this plus is going to become just cosine²𝜃. Could I write over 1? I could. Should I? I don't know. I think it's a little silly. Then from here, oh my gosh, we love this. This is a Pythagorean identity. It equals 1 and you're done. That's it. Okay, finished. Now what's the more maybe intermediate level, more experienced person level approach? Well, and it might be beneficial next time, right? This one worked out great this time, but every example is a little bit different. Techniques, there's a time and a place for everything, right? So I notice in this one, I have a greatest common factor. I'm going to factor out sin²𝜃 from both parts, in front of the plus sign and after the plus sign. When you divide out or undistribute sin²𝜃 from sin²𝜃, you're really dividing it out, because when you distribute it back, you multiply. So what's left is a 1 plus, and then here, just the sin²𝜃 is gone. So out of these, what's left behind is just the cotangent² 𝜃. Now, you might be thinking, like, why am I watching this? This one was fine. Hey, by all means, fast forward, click to the end, and go to the next video. But if you stick around, this is helpful for a lot of things. Now, here, I'm going to go over this in a video coming up soon. I go over how to create all three Pythagorean identities from the original, well, how to create the other two from the original one. And this is the left-hand side of one of the Pythagorean identities, and this is equal to cos²𝜃. And that's being multiplied by sin²𝜃. Now I might think of panic mode. sin²𝜃, I'm really multiplying it by 1 over sin²𝜃, since cosecant is the reciprocal of sine. Again, this is over our invisible 1. Anything divided by itself is 1. So in either situation, whatever way you do it, you're going to get 1. Don't compare yourself. Maybe if you're like, doing homework and comparing with a friend, don't necessarily compare yourself with somebody else's technique and cross yours out. You might not be wrong. You guys might both get to the right answer. And to me, that's even better if you could both use a different approach and you guys simplify it to the same thing. I mean, that's like the best justification or validation that you're both right. So hopefully this was helpful for you. If you are happy with everything and you're like, wow, I'm so good at this, go ahead and give the video a thumbs up. Not so happy about it, go ahead and put a thumbs down. Have another method or a suggestion, put it in the comments, or you can just go right ahead and click through to the next example or the playlist. And I just hope that you are feeling smarter right now. Adios.